Welcome to this presentation about SiFive Event Trace, the first zero overhead performance tool for RISC-V processors. This is the agenda. We'll go through a little bit of the objectives and what it's all about, and also an invitation and how this can be used to actually do performance analysis of your software. So usually when software developers want to do profiling and performance analysis, gather performance analysis of their software, they usually have to do instrumentation of the software in terms of to inject certain instructions, certain code, certain places to actually do the collection of the traces, which unfortunately gives an overhead, adds an overhead to the software being profiled, meaning that you are not actually profiling the production code software, but you are profiling your instrumented software instead, which can change the behavior of the software, meaning that you might be profiling something that was not actually present in the production code. So the new approach to do this better is SiFive Event Trace. So what is this? SiFive Event Trace is a hardware implementation in SiFive processors that allows the hardware to collect events, the similar event as you would get from instrumenting the software, into your trace stream of your hardware trace, meaning that you do not have to recompile your code. You do not have to instrument your code. You are actually profiling your production code, meaning you are actually profiling, getting the data from your production code that you want to actually do tracing and performance profiling of, and to find timing issues and stuff in. So how does this work? This works by, we have added this to the existing N-trace specification that is already a ratified, almost ratified part of the RISC-V organization. So what Event Trace does is that it adds the possibility of adding trace messages into the trace stream of calls, returns for exceptions and interrupts, and context changes, watch points, and external triggers. A little bit the same as you would get from instrumented code, but this is the hardware that actually goes in and collects these data, so it can generate messages into the trace stream with the program counter at that specific time where the interrupt of the call took place, or watch point you set in. And the benefit of this, an added benefit of reusing the N-trace, is that you actually get these high-resolution timestamp, which is part of the N-trace specification of the trace messages already, which is very useful for performance profiling, so you get very exact numbers because it is generated from the hardware taken directly from the counters. So this is one thing that you can actually collect this. On top of this, we have added profiling performance counters, which is, if you already know about hardware performance counters, which is what can count the occurrence of specific events in your system, like cache misses, or branch misprediction, or like a number of certain instruction types, all sorts of stuff. This has been added to the event trace system as well, to be able to collect these, but instead of just counting on top, they are reset every time that a event trace message is being generated. So they're counting delta counts, so you can use them to count the number of events between, for example, when a function is being called until it is actually returning from that function. So it gives a very detailed performance number. It gives a very detailed numbers from these counters that you can actually use in your performance analysis. And you can reuse, so you can run the same code again, and you can tweak which counters you actually want to be counted. There's a limiter, of course, on how many like there is with hardware performance counters, to how many events and counters that is available in this setup. But as you're just reprogramming the hardware and you can rerun your production code, you can do a lot of deep investigation and do different profiles of your production code using both event trace along with profiling performance counters, which gives a lot of. So, and the condensedness of this is that it can either be 16-bit counters or because you do not necessarily care about the exact precision if there's a long duration. And you can set up these counters and also the event trace to actually only count specific stuff. And you can also set it up so that it only counts for specific privilege modes, as well as if you're in a Linux system, you can set it up so that it only counts if it's in one specific process with a specific process ID. So you can target it in so that the amount of messages being generated into the trace buffer doesn't fill up too quickly. So you can guide it in and set up triggers so that it only collect event trace messages for a specific part of your program you're interested in profiling, which makes it a very flexible tool. So with all this new features, we have, at SiFive, put this in, this specification into the RISC-V organization, donated it so that the whole community can benefit from this. And it's currently in the debug trace and performance monitoring SIG group. It's being discussed, the details of this, and if it's good enough, or there might be some extra details that, and we also need, when this gets ratified or gets closer to ratification, would encourage the software community to tip in to actually either create new tools or extend existing tools to actually leverage this functionality for doing performance profiling, like the KU trace from DigSight, or doing it for debugging or algorithm analysis using point-to-point events. There's a lot of different metrics that can be, that this feature can give to you to actually do performance analysis, and we think a lot of tools can benefit from this because it's similar to what you would get from instrumentation there. So there's a lot of existing tools that can probably be modified to actually use this. So how do we actually provide access to this as part of the SiFive delivery of tools? It is possible to when you are buying a SiFive course, you can select whether you want the event trace to be part of these courses. And if you do that, you also get, along with the delivery, access to SiFive Freedom Studio, which is an IDE for software developers that contains all tools and analysis that benefits from this event trace for you to get started with actually doing software development. So one thing that we do is, if you, for example, in this case, if you want to visualize how much time is being used in a different function calls, this has been set up with actually doing event trace of function call and returns. So alongside with this, you can see there's a lot of low-level details that you get into. This is a pretty raw view. But this feeds into the open source plugins of Trace Compass. I don't know if you're familiar with this, but in the Eclipse setup, there is a huge amount of visualization in Trace Compass. It allows you to actually deep dive into and use these for visualization of the performance profiling data collected by event trace. So you can see, for example, a flame graph or a flame chart where you can deep dive into and get a visual overview and also get the some statistics on top of the raw view that I presented before. The other thing with the profiling performance counters, here I have an example where I've inserted a watch point into a loop. So this is kind of interesting in terms of, you can see that the counters, the PPC counters, is counting up, for example, for instruction, for cache misses, and for branch miss prediction. So you can see in the beginning of the loop, they do count certain cache miss prediction and branch miss prediction. And the further the loop gets down and iterates, the cache has been filled up and the branch predictor is kind of aligned with predicting the branching. So this is a very powerful tool to see if you can optimize, so for example, in this case, a loop. And there are also visualization in Trace Compass that allows you to visualize this in a graphical way. You can, in a histogram way, more visual impression of this, and then also some statistics along with this. So the benefits, just to recap, of SiFive Event Trace is that you do not need to instrument code to make this, to utilize this feature on the SiFive cores. And you also get very precise timestamps along with the PC where the event actually occurred. And this is all available in the SiFive Performance and Intelligence course and on the latest generation of the SiFive Essential course, and on our HiFive Premier P550 board that is already demoed in the exhibition hall. Yep. Thank you. Questions?
Thanks, Carsten. Calls and returns obviously are very common in code. Do you find that the bandwidth of tracing them with event trace is lower than the bandwidth of just doing full instruction trace?
Yeah.
Or has that been measured? Yeah.
I would say that it is considerably lower, especially if you have code, the code that actually does a lot of, where you have functions that are very rich in terms of things going on within a function, then instruction trace can quickly fill up, whereas event trace, you only capture it on when you're going into the function and then when you're returning from the function.
Right. I guess more the question I was asking, I guess, is like, have you done that comparison? Do you have data, or is that just sort of a...
We have some data,
okay,
but I haven't done a deeper analysis of it.
Okay, thanks.
Yeah, I'd say that's going to depend on the characteristics of the program, right? Most full trace won't trace most calls at all, yeah. And so no address is generated for those. So that would significantly, I guess it depends on how big the functions are, how many branches they have in them. If you've got lots of small stub functions, then I think this would generate a lot more trace. Than,
yeah. Yeah, certainly. But you can target this into actually, you can set it up so that it only collects for a specific part of your program.
Sure.
Like you can for instruction
sure.
trace as well, of course, so you can make sure. But yeah, it's always a case about filling up the buffer too quickly and not getting the data you actually want.
Yeah.
So it's not a question, it's a comment. I mean, as you mentioned, the spec was donated and will be picked up by interest groups and everybody. So we discussed this already, and even like yesterday or Monday, and this is great addition, I think. Thank you.